Hello everyone, welcome back. In previous video, we have configured Docker to create two containers, Mongo and Golang app. Create configuration file and use Viper to read it. Also, we are able to make MongoDB database connection from Golang app. Today we begin by creating database models package. This package consists of to-do update, and to-do delete models. To-do model contains user ID as integer. ID as interface. We have to declare ID as type interface and set on empty flag so that it can handle Mongo object ID type. Title is string and completed as Boolean. To-do update models contains the number of record modified and the updated record. And to-do delete models contains the number of record deleted. Next, create to-do interface which contains all functions to communicate with the database. Create to-do.go file and database package. Create to-do interface with insert, update, delete, get, and search function signature. Create to-do client which contains context interface and a pointer to mongo.collection. This will give us access to all functions of Mongo collection. And finally, declare the function implementation as below. Insert function accepts to-do object and return to-do object with inserted ID. Otherwise, return an error. Update function expects string ID and update as interface. It returns to-do update models or error. Delete function expects string ID. It returns to-do delete model or an error. Get function expects string ID. It returns to-do model or an error. Search function accepts filter as interface and returns array of to-dos or an error. These are wrapper functions over the actual functions provided by Mongo package so that we can mock them when we do unit testing. Now let's implement insert logic. First, create to-do variable instance of to-do models. Then, call Mongo insert own function to insert into the collection. If an error occurred, then return empty to do an error. Otherwise, convert the inserted ID into hex string. And call get function to get the inserted document. Next, let's look at the get function. It expects a string ID and return to-do model. First, create to-do variable instance of to-do models. Convert string ID into object ID. Then, call find one function with the ID to search in Mongo collection. If an error occurred, then return empty to-do model and error. Otherwise, return the to-do model and nil. The next function to be implemented is the search logic. It accepts filter interface and return array of to-dos. First, create to-dos variable instance of array of to-do models. Check if filter is nil, then set it to empty and .dem. This will return entire collection. Then, call MongoFind function with the context in the filter. This return a cursor, which we need to loop and append the result. Loop through the cursor using next function. Finally, return result and nil. Delete function is the easier one. It will return deleted count of 0 if record is not found, and 1 if the record found and deleted successfully. So first, let initialize result deleted count to be 0. Then convert ID string into Mongo object ID. And call Mongo delete one function. If success, return deleted count equals 1. The update logic is a bit more complex, as we want to perform update only when the data change. First, initialize result with modified count equals 0. Then, convert ID string into Mongo object ID. Call the get function to search for the existing record. Then, convert existing record into map string interface so that we can compare against incoming data. Also, convert the incoming data into map string interface. Loop through each field of incoming data and compare against existing record. Delete any field that is not changed. If no change found, then return modified count 0. Otherwise, call Mongo update 1 to perform the update. Finally, call the get function to get the update record and set modified count to 1. Return the updated record. Now, go to main function and start creating all routes we need. But first, create a context variable which is needed for Mongo operation. Pass the context variable into connectDB function. And modify connectDB function to use the new context variable. Next, get a pointer to to-do collection. Then, save the collection pointer and context into to-do client variable. Now we can create a routes. First, create get to-do routes, which call a search to-do handler and accept to-do client. Second, create get to-do routes with ID, which call a get to-do handler and accept to-do client. Third, create a post to-do routes, which calls insert to-do handler and accept to-do client. Fourth, create a patch to-do routes with ID, which call update to-do handler and accept to-do client. And finally, a delete to-do routes with ID, which call a delete to-do handler and accept to-do client. Next, let's create the handlers package to support these routes. Create a new folder called handlers. Create a new file insert to do.go. Declare package name handlers. Create function insert to do, which accepts a database client to do interface, and return HTTP handler function. The HTTP handler function expects two arguments, HTTP response writer and a pointer to HTTP request. Now, create a to-do variable with instance of to-do model. Read in the request body and convert into byte. Return 400 response if an error occurs. Unmarshal the body byte into to-do object. Call database insert function to save the to-do object into the database. Return the inserted records with ID as JSON and status 200. Let's refactor our response so it is easier to call in other handlers. Create a new function write response, which accepts HTTP response writer, status integer, and response interface. Copy the response writer from insert to do into write response function. Change http.status OK to status. Then, we can replace all the response writer called by write response. Next, create a new file update to do.go. The update to do handler function has the same signature as insert to do handler. So we can just copy from insert to do and modify the body. Remove to do variable. Get the ID from the URL parameter string. Since we allowed partial update, we will declare to do as an interface. Replace the insert with update function and pass an ID into do. Next, create a new file delete to do.go. This one is similar to update to do, so just copy everything from update to do handler. Change function name to delete to do. We don't expect request body, so we can remove request body conversion in JSON unmarshal. Then, replace update with delete function, remove to do parameter, and we are done. Get to do is similar to delete to do handler, so just copy everything from delete to do handler. And change function name to get to do, and replace db.delete with db.get. Finally, create a new file search to do.go. Let's copy everything from get to do handlers. Change the function name to search to do. Remove the ID parameter, as we don't expect the ID in parameter string. Declare a new variable filter as interface. Create query variable to hold the query string. If the query is not empty, then unmarshal it into filter variable. Finally, replace db.get with db.search and pass in filter. Now let's start our application and give it a test run. Go to Terminal, enter command docker compose up -- build. Once both containers are up and running, open Postman, send a post request to create our first to-do item. In the URL, enter localhost :8080/todos. In the Body tab, select Draw and type JSON from the dropdown. Let's say user ID is 1, title is Learning Golang, and completed status is false. Click on Send to submit the request. We can see that the record is saved in the database and return with valid MongoID. Now let's update the status completed to true. Copy the MongoID into the URL, change the post method to patch. Remove everything from the body and set completed as true. Click Send and we can see the result with modified count as 1. If click Send again, we will get modified count as 0 and record is not updated. Next, let's delete this record. Change the method to delete. Click Send. The response says deleted count equals 1. If we click Send again, we get response deleted count equals 0. Now let's create a few to-do items. The first item is Learning Golang. The second item is Learning Docker. The third item is Learning Mocking. Copy the MongoID and parse it into the URL to test our Git root. Change the method to get and submit request. It returns the record related with the ID. Finally, we can test the search functionality. The search expects a query string of name Q and JSON string body. Let's say we want to search for title Learning Docker, so we can enter the query like this. It found only 1 records with title Learning Docker, but in array format. Now let's update completed status of Learning Docker to true. And then we can query completed status as false. It will return 2 records, and Learning Docker is not one of them. This is the end of today's video. In the next video, we will write unit test and mocking the database call. Thank you for watching. Please subscribe.